This video is to help explain how to do partial quotients. We're going to start with the problem 432 divided by 6. Now to start this we would rewrite it in this format. So we say the divisor is on the outside, dividend is on the inside, and we've talked about making a house for it. First thing that we do is look at our number 432 and figure out how many 6's could we put into 432. We want a number that wouldn't go over, so we wouldn't say something like 100 6's, because that would be 6 times 100, which would be 600. That would be too many. So we want to take something that we know is going to work. We don't want to start with 1, because that would take forever for us to take out a group of 6 each time. So an example here would be to take out 20, because I know as a student that 6 times 20 is 120. So I should be able to take that out of 432. So 20 groups of 6 would be 120. We started with 432, and now we're taking out 120, which would give us 312 left. So next we need to say how many 6's go into 312, sorry. At this point we could say the same thing. Well, I know a group of 20 goes into 312 because I know it's 120. So we do it again. This time when we subtract, we have an answer of 192. That's how much we have left. So now how many 6's go into 192? We can do the same thing, 20, which gives us 72 6's left. Okay? So now we need to figure out how many 6's go into 72. Well, we know that 6 times 10 is 60, so we put a 10 on the outside, do 6 times 10, which is 60, and we take that amount out, leaving us with 12 left. We know that 6 times 2 is 12, so we can get out 2 groups of 6, which is 12, and we have nothing left over. So we have no remainder. This is where our remainder spot would be. When we're all finished, we add all these in our column for an answer of 72. Now you might be saying to yourself, wow, Mr. Pleim, that took forever. And that's true. If students know their facts, this can go much quicker. So same problem. If I know that 6 times 7 is 42, then I know that 6 times 7d is 420. So I can take out 420, which gives me 12 left. And how many 6's go into 12? That was 2. So my final answer there would be 72. As you can see, much less work than taking out little chunks at a time. That's why we didn't start with 10s or 5s or 1s. We tried to start with a larger number like 20, something that we knew. So that is partial quotients. Another strategy that I've taught the students today was to set it up a little bit differently. I put some scaffolding in place or some supports that might help them. So same way of setting it up, 6 and 432, and then we created a T-chart. Now this is for the students who are uncomfortable with their basic facts. The T-chart can help them. So it's a times 6 T-chart, so 1 times 6 is 6, 2 times 6 is 12, and so on. We go to 5, but the students could go all the way to 10. So if they wanted to go 5, 6, 7, 8, 9, and do 30, 36, 42, 48, etc., they could. But we can also just stop at 10. I'll show you how. So now that we have our T-chart, we know some of our facts, and we can tackle this problem. The first step in this new scaffolded method would be to say, how many 6's go into the number 4? And we know that no 6's go into the number 4 because 4 is smaller than 6. So now we expand that out. How many 6's go into 43? And we know that 5 6's go into 43 because 5 times 6 is 30, which we can see over here in our table. So 5 times 6 is 30, but we didn't do anything with this number 2. So just like in our partial products multiplication, where we put a dot whenever we needed an extra 0, we used 43 and did not use this extra 2. So that's where that dot comes from and that 0. Because what we're really doing is 6 times 50, which is 300. So going back, we did 6 times 5 is 30, But we're not just subtracting 30 from this number. We want to subtract out 300, a larger number. So 6 times 50 is 300, and now we subtract that, which is 132. Again, after getting 132 as our answer, we say how many 6's go into our new number, which is 132, 1 in this case. We know that no 6's go into the number 1, so then we expand it. How many 6's go into 13? So we look over here, we know that 2 6's go into 12, and so we couldn't do 3. So that's where we get our number 2 here. 6 times 2 is 12. But again, we did not use this 2 at all, so we can put a little dot next to that, and then put a dot out here, because 6 times 2 is 12, but we want to make this a much larger number. So what we're going to do is expand that out into 20 times 6 is 120, and then we have 12 left after we subtract. Next is how many 6's go into 12, which we know from before is 2, which gives us none left. Now our answer is right here. 50 plus 20 plus 2 gives us 72. So those are the two methods that students learned in class over the last couple of days. Some students are really proficient with this. Some needed the lines and the dots in order to understand how to do partial quotients. Let me know if you have any questions via email or phone. Thanks.